I think we're good. Okay, so it's the lab meeting on January 30th. All right. Any time conflicts today?
Maybe by 11.
Meet by 11. All right, you're not the only one.
I have to be pretty early as well.
Okay, you want to go first?
Sure.
Okay.
The Hoshi Express. You want it? Is it
Yeah.
where you taking?
One of them, I used to be bride, so
Yeah,
one of the buses.
there's one. You go to the
Was that
also.
Palm Springs? That was not the same. At least from memories.
Yeah.
I'm not sure which one's best.
All I know is I took the Hoki Express coming back or coming over there last week. And it got me the Newman, so. I think what they do though is they put out their time check it and or Lake Word, so. May not be able to get all the way over there, but.
Oh, we need to share the screen on this thing.
Sorry?
Palm Springs would get me over there, but like.
No, I got two. Newman. Maybe like 5 minutes to spare to walk up.
That's great. Do you have animations?
No,
Yeah, we can just click through then. That's okay. We can fix it on the back end.
nothing is happening.
Oh, nothing is happening. Oh,
It's
goodness.
not responding to anything.
Maybe it's a range thing. You want to slide back this way? Nothing?
It's like,
False start.
it's like not today.
Happy Monday.
There we go.
There we go. Okay. So. Did we talk about, we sort of talked about this last week.
Can you give a quick 1 minute introduction for Karen and Derek because they're new?
Oh, yeah, okay, so I guess. The whole goal of the project that we're doing is to try and make a way to like. Visualize and play with point clouds in VR. And so we're using A-Frame, which is like a web VR development platform. And right now we're just working on loading the point cloud, which is hard. So yeah, this was something that I found where this was in the package log, in the package.json for the poetry loader, which we had found that didn't work any version past 0.9.2 for A-Frame, and that like could have been why. I played around with it more, and it just like caused more problems when I changed the version. So it might, I don't know, I'll look into it later maybe, but
Okay.
It's not like an easy like boom, boom,
Just change the
done.
version, hit
Yeah, I
go,
was
yeah.
hoping it would be, but it was not. But it doesn't mean it's not possible. Okay, and then in the 3D Tiles reloader component thing, I've been figuring out more about how all the different layers work. Because we're working with a A-Frame component that is built off of the 3JS component. And then I figured out how to like modify them all using these NPM scripts. Because those like create the like distributed version, which is just like all of the code just like smashed into one file. So I was like modifying them and nothing was happening on the front, and I was like, why? And that's why.
Okay.
But it's like different commands for each one. So that's mostly just a note for myself to remember which one does what.
Great.
And then, so this was able to load point cloud file. This one didn't quite work yet, but it did try to access it. And then I fixed some more stuff and it actually worked. Sort of. It shows up like in the attributes part, it has like color, which is like that is the entire point cloud in the attributes. We've got 4.9 million classification data points. I checked them, it's like 2s, then it's 3s, like it's there. And then there's like 4.9 million sets of XYZ data and 4.9 million sets of like RGB alpha data. So it's like, that's the point cloud.
Yep.
But nothing shows up yet. And then I was able to get that, because that was, the first one was on the 3JS layer, and then I was able to get it to back to the A-Frame layer by like returning it through the stuff, which was more complicated than I originally thought it was gonna be. And so then trying to turn it into something that actually shows up on the screen. And I think it has to do something about the object 3D and the geometries and the meshes and stuff, which I'm still learning about. But
So
basically-
it's a how to draw issue, not a like how to load it, right?
Yeah, the
Yeah.
loading is done. It's just a moment of
Sweet.
how to like get it onto the scene. And so I compared it with like a normal sphere, and I think because the sphere has children and a mesh and a geometry, and mine does not. So that's
Okay.
the goal, is to get it to work. And I found this code on the internet, which sort of shows how to do it, so I've been playing with that. And it doesn't work yet, but I think that's the way to make it work.
Yeah, this is great. I think, what do you think about looking in the Poetry code and
I've
seeing,
been trying to, but the poetry is just like an entirely different thing.
Okay.
Like the poetry is hierarchical and this is just a list.
what
So I
about the,
think-
what about the drawing? Same problem?
I think, because I've also been trying to look into how the 3D tiles work, and the 3D tiles is a whole different thing, so I think we're just like.
Okay. Okay.
Have to do our own thing now. But I don't know,
Okay,
but I think. I don't know,
all right.
I'm pretty sure it's possible.
Well, this is great. This is a good week.
Yeah.
Good job.
I actually have time this semester to do things, so.
All right, Karen, you said you've got to go, but you're not presenting today, right? So, okay, so we'll pass it down this way. And I've got it set to like full resolution, so everything's kind of tiny, so we'll have to see if this is gonna work, but it also makes the Zoom stuff tiny, which is kind of nice, kind of out of the way, so we'll see how it goes. All right. Oh, it's already open, okay. Couple of fun things. One, this came across my desk over the weekend. The MIT Lincoln Labs, which has a lot, it's technology in support of national security. I heard Lincoln Labs referenced, but I didn't know what they did exactly. One of the things that they came up with was a way to create toroidal propellers. And they did it for this, and then the article that I found was actually like I forget where that came from, but same sort of like toroidal propellers for boats. And the interesting thing is that it creates less, it basically like tears the air less, or distributes the tearing over a larger area. So the net result is that it's a lot quieter. So this just came out 2 days ago. The big sort of press releases, maybe 3 days ago now. So I think it's going to be a big step forward. I think a lot of people are going to license and copy this design. When they were prototyping this, they said that they 3D printed them. I did a half of a look to see if like there are any out there, but if it can be done and somebody sees the idea, then probably we're going to start to see a bunch of these on Thingiverse. I've never 3D printed a drone propeller before. I've had concerns that they might not be robust enough to handle the job, probably fine for prototyping. But we might be able to see how things go. And I bet within a year, we'll see these things on the open market for distribution. So just a neat, clever idea. Noise is a big issue for these things. Like they really freak people out. I was flying over my property once and my neighbor, heard the buzzing and then sees that I'm flying a drone, and like it was a whole big thing. So I think this is going to be a better idea. This is the ASPRS, is the American Society for Photogrammetry and Remote Sensing. We just got a word in the department meeting the other day that Jim Campbell, one of the emeritus professors in the department, is being honored with a Lifetime Achievement Award by the ASPRS. So it's a really big deal. They don't give a lot of those out. But this is going to be a virtual conference. So a lot of what we do is photogrammetry and remote sensing. So this stuff could fit in well here. Abstracts aren't due till May 1, so we've got some time to sit on it. The conference itself is June 12th to 16th and virtual. Virtual conferences aren't amazing, but on the other hand, it's a low cost. So that's nice too. Some 3D thermal modeling stuff. This is mostly just news for you. So we ordered the little USB device that kind of goes in your phone. So there's an iPhone version of that that's on its way. probably here this week. I have a, a quarter resolution version of that. That's a USB-C for my phone. And so I wanted to just kind of, while we're waiting for the new one to come in, I wanted to sort of see if you could ice some of these pictures together. That's a way to sort of just stitch a bunch of stuff. So I took like, I don't know, 10 different photos like this. It adds the, it basically uses the RGB channel. You can see that it takes a thermal photo and it takes an RGB photo, and it basically takes the edges. There's an edge filter that gets applied, and then those just get sort of like overlaid on the thermal. So I thought it might stitch. I basically just walked across my house that way. It did not stitch. I got part of it. I mean, I got part of it. And this might be sort of what you were showing me last week. You get, you know, I went all the way to the end of the house. You can see that I've got a lot more than just a single image. It looks like at least 3 by the stair step pattern there. But it didn't do the whole house. So I'm not quite sure what the reason for that is. But otherwise, I think it looks pretty good. One of the interesting things is that we're not getting as much contrast as we could because the sky is showing up like super cold. So that's like, we would probably want to, like, that's just a good thing when we go out there. We'll want to figure out a way to like clip that out probably and just make it transparent or something beyond a certain threshold. This is the app that I was using. FLIR has its own apps. When you get the one that we ordered, you know, play around and see what apps are out there. This is sort of like developed in concert with FLIR, or at least it's like with their approval or something. So it's not just some nobody, but FLIR has let some development happen, which is good. Some RTK GPS news. This I post some of the stuff I posted into the Slack channel. But one of the really exciting things is that I just discovered that so basically RTK GPS works by one static GPS providing corrections to a second one. This was not provided in real time. You could, for a long time, you've been able to go and download like yesterday's corrections and apply them, kind of post-processing, but not a lot of real-time correction was available. So I've got one on my roof. Well, you can't really see it, but it's right around there. Providing corrections for us in the lab so that we can take our equipment out and we'll have those corrections. But what I just found out while I was messing around with this, because that had broken, the connection between them had broken, was that the Blacksburg Airport GPS station is now broadcasting its corrections live. And that's exciting. There aren't many people doing this on the East Coast. So on the West Coast, this gets super dense, like any place that's geologically active, there's a big input in that stuff. So like California's network is huge, but like that's us and that's it. And that's brand new. So that wasn't there. I don't know when it got turned on, but it wasn't there a couple months ago. So really great stuff. The other one, did I mention this? There's another VTTI, the Virginia Tech Transportation Institute, also has 2 of these running as well. So that was news. They're running in the same channel as we are, which is this RTK2 Go. It allows you to sort of publish, individuals can publish their own streams. So Blacksburg Airport is publishing theirs via UNAVCO, which is kind of this like international organization for this stuff. So there it's a little bit more official. And this is, you know, VTTI is doing what we're doing, which is just like throwing it up there and anybody can use it. But both of that is really good news. I wanted to see if I use the airport corrections to establish the position of the one on my roof. So in the past, I'd sent it to OPUS, which is the National Geodetic Survey's way of providing these corrections. You get like, you know, yesterday's log and you give it to them and they come back and they tell you where it was. Not real time. So I wanted to use the airport. I got these numbers and basically what I found out was that it is slightly different than the other one, and that's due to a datum issue. So it matches the ITRF or WGS 84 location, but we want to use the NAD 83 2011 version because that's what all our LiDAR data is. And so if we want to fuse these things together, we want them to be in a common framework. And you can just translate one to another. It's just a projection issue in GIS, except you got to keep track of it in 3D instead of 2D. But it's easier if it just aligns straight up. Stuff from the build project, a lot of little stuff. This was one of the last things we did actually on Friday. But it relates to the data that we gathered, and Addison might talk a little bit more about why we were gathering this data. But we hadn't pulled in all of the, so Percept is the system that tracks what the LiDAR is doing and then tries to figure out objects moving around in the space. And we haven't had that, we haven't looked at that data. So it only started, Blickfeld released an update for that in maybe December. We got that put on there, and I hadn't actually analyzed any data. So Addison took the reflector over and did some stuff. He'll talk about that. But we wanted to look at the data, so we pulled it off, and I got a script that translates the JSON data that you get from the Percept system to just like a shape file. And we're only pulling in part of the fields that we needed. But it did work. So this is the shape of the CID. You can see all of these little spikes. So these are like noises as it's like jumping around, and we're never going to get those out probably. So it's just a question of how do we factor those out. So we haven't, this is just like brand new. We just figured this out on, or just took a look at this on Friday. One of the things that we did try was to calculate the distance observed in the track. And then maybe we can use that as a filter, because the real data should exhibit distances of more than a couple. But we think the noise is likely to have a very different pattern. These little sort of like short bursts that won't look right at all. So we'll see. Anyway, we sorted this by distance, and Addison thought that this was one of his own tracks. So I think that this is a good step forward. We're building a test bed of the LiDAR. So we were in a huge rush to get everything built over in CID sort of as we got the money and as we got the parts and stuff. So we've just had a production system over there. Which means it's at work gathering data that we need for the research, right? It's not, we can't fiddle with it. We can't play with it. We can't, like, to a very limited extent we can, but we have to be careful because we need usable data off of that thing. So we're going to build a copy of that whole thing here. So we turned that machine into a Linux box. We're trying to document everything about the whole install, not just the Linux stuff, but like all of the LiDAR setup and everything. Some of that stuff is detailed in wikis. Some of it in lab reports, but we're going to try to pull it together. But my vision for this is that we've got 4 LiDAR units extra, three of which will go back in the CID when we get a chance to do the installs. But for now, we could use them as test beds. So we've got one sitting, well, I had it sitting up right there at the beginning, but we'll probably put 4 of them in here. And I don't think we'll leave them on all the time, but we can turn it on and we can gather data and we can see how stuff works. Try out algorithms, try out this, try out that without having to mess with the real thing. So good start on that. Percept 163 is out. So we're running 162, so we need to do that upgrade at some point soon. Percept is running. So the thing that kept us from turning it on, so I said that they fixed something in Percept to let us track all 11 sensors simultaneously, but what they didn't have yet was a way to fix this firewall issue. So the idea is that the whole LiDAR system runs on what's called a private network, right? So not everything is plugged into the internet. So we have all of that data pooled on a private network that doesn't actually directly connect to the internet. But what does connect to the internet is the logging computer. So it's got one sort of private facing adapter that looks at the network, and then it's got a public facing adapter so we can pull our data off. So it's like the bridge between those two things. What happened was when you're running Percept, it messes with the network connections and it basically repeats everything that's happening on the private network to the public network. So everything was just totally 100% like usable. So anybody could just pull up, like what it does is it opens up a web page and then you can interact with the sensors, you can delete projects, you can do whatever you want to it. And there's no password, there's no anything. It's just like, hey, would you like to play with our LiDAR network? So that was not going to work. So we would only leave it on for just like brief points in time, like Addison's going over to do a test, we'll turn it on, he'll do the test, we turn it back off again. So relatively secure. They did come up with a way to fix the issue. It took them 2 days to figure it out, and apparently their like CTO had to like get in on it. But the way that the Docker containers work was so complicated that it took some doing to figure out. So I'm glad that we didn't have to do it. There was a lot to know. So anyway, they figured it out. There's a couple of steps. I've got all of those documented. I still need to, the firewall doesn't start back up again after we made these changes. It had been working just when we did them, and then I did something and then it kind of stopped working. So I've got a couple of little things left to do, but it still prevents the use of the system. So it's actually been running now over the weekend. You can't access it from outside. So all good things. They said it's better if Docker doesn't need sudo, so we changed that. This is the instruction for that. These are just some notes, again, mostly just for me of what we did. Basically, they've got a little script that tells you what rules to add to the firewall. So you add those. And then you basically add this data to this like etc UFW after rules. And then between the two of those things, that does the job and it prevents Percept from just opening up to the whole world. I also changed the access port for the remote desktop to 43389. So again, it's kind of just a note to myself, but you guys will need that at one point. And then one last little bit here. We want to try to use these reflectors to maybe track what's going on. It's a bit of a harebrained idea. Probably what we're going to do is use the indoor positioning system to test the system. So we'll set the IPS up and use that. But we thought, could we just use a reflector? It's just light after all. And so this was Yotaro's. This is Yotaro's. This is the Cully Hessian's lab. Does a lot of LiDAR work. So they have this nice GCP LiDAR target that shows up in the cloud here, and it's got an intensity value in the LiDAR stream of about 5,000, whereas this little sticker that we bought on Amazon for $10 for like a sheet of them gives us a reflectance value of 4,300. So that's pretty good. Addison, you are 2,500. So I think it does a pretty good job of separating out people. So the idea is we put this on some moving object, but a wall is also about 4,300. So the door was 4,300. So that didn't work out exactly. It's a step in the right direction. I'll play this. This will just take a second. But I just wanted to record these values for, so there's 4,300, there's Addison at 2,100, depending on where you click, they'll give you a different number, but some separation out. And then we're getting this ambient channel, which is not a typical LiDAR channel. We're getting it from the Blickfelds. That's showing up super bright. So the sticker is giving us an ambient value of 3,500 or so. Yotaro's target is 9,500, but still it's a good difference between either of those two things and like everything else. So it's showing up as a light source, in other words. So I think we've got some ways that we could maybe use this. I would consider this sort of a reasonable success for the target or for the money. That target is like hundreds of dollars, so it's nice to be able to, and we don't want to, it's big and it's heavy, and so I think this is a step in the right direction. Lots to do. So I've got to finish Colleen's paper. Jim Young's paper got a major revisions back. So he published his thesis and then we submitted the manuscript based on that for publication. They came back with a review on that. I don't know if I mentioned this, but major revisions is a good one. So they can either accept it, which they never do. They can say, you need to revise things a little bit, which is called minor revisions, which is sometimes happens. Major revisions is a good result. And then way more than half the time they just reject the paper outright. So we were happy to get that result. But I need to make those edits and submit. Bye, everybody.
Sorry.
Oh, that's right. I want to test distance on the rover. So I want to make this a goal this week. All that's entailed there is turning it on, a pair of us doing it, one person walking beside the rover as we drive it as far away as we can. So that should be fun. I want to teach you to do a whole drone gathering mission. We won't do GCPs. You're going to be doing that separately. So I want you to continue to do the with the points, but we'll do a drone flight without one, and you can just sort of see how that goes. I used to fly a lot of my missions without GCPs. I don't anymore because it's a nice backup and it prevents some difficulties down the road. If everything works fine, you kind of don't need GCPs. but it never works fine, is what it amounts to, and so you might as well just have them because you're gonna need them at some point. And then I want to test fly the Hexoon. That's probably just a me thing this week, and then maybe fly at Kentland. Probably not this week, probably next week, given my schedule. That's what I've got going on. Vincent, you've got one?
Yep.
Yeah, it's really small print. Sorry, everybody. Get a
Oh no,
telescope.
like my presentation is really small.
Oh, your presentation is really small.
All right, so I just wanted to share this website with you all. That's this called Scriber. So this is mainly for like for generating references. So if you have like a DOI number, or you have a web page link, or you have an ISBN number, you can just put it in there. It will search and it will get back with you with the reference and whichever style you want. So I know lots of people are using like Mendeley, or like there are like some other software that are available for like references. But the problem I faced with, like, I was personally using Mendeley, but the problem I was facing was like, if it gets over 100, sometimes the software doesn't manage it well, or the output gets messy. So this is not like keeping track of all, this is not like a repository of all your references, but at least it does a job like, okay, so I have this link, you need this immediately. So it just gives you the output. So it has really helped me throughout my thesis writing. So yeah, I'm just putting it here. Anyway,
The Google Scholar formatting is never right.
Yeah.
So when you go to publish these things, journals are exceptionally picky that everything is in exactly the right format. So, and you don't want to have to do, I used to just do this stuff by hand. So this is a good, thanks for sharing. Scriber.
okay, so Dr. Pingle gave me a small assignment. That is because like in one of my in our paper, we I cited a reference which was mentioning that resolution and scale is the same thing, but which is actually not. I'm not sure why I did that, but so this is just like a definition of like what is resolution, what is scale, and what is extent. So resolution is actually resolution actually refers to the small distinguishable unit in a raster. So like, let's say I guess we all know this, but like if the resolution says like it's 30 meters, that means 1 pixel actually denotes to 30 meters into 30 meter area. So that's the resolution.
And I'll note that vector data can have resolution as well, right? So the cartographic boundary files for the census, for instance, are produced at 3 different scales. This is going to tie into your other thing. Intended scales for use, but they effectively are the resolution of the input data. The reason that we're talking about this is because these are 3 very interrelated concepts, and they play together in sort of interesting ways, right? So yep.
Yeah, so the second thing is the scale. The scale is like the size of any actual thing on a map. So let's say this is actually 10 centimeter, but on a map, this is size 2 centimeters. So the scale will be like 2 centimeter is to 10 centimeters. So that will be the scale of it. And the extent is the area that I'm covering in a map. So that could be like, so if I have a map of this whole table, so the extent will be the area of this whole table. So that's what these 3 things mean.
Scale and extent can also sometimes be used synonymously, so you have to be careful about that. So this is a global scale problem, right? Or can we scale this up? You come up with a solution here, can we scale it up?
Yeah.
So sometimes scale can be used synonymously with extent, and that's fine. English, like, it's not an incorrect usage, it's just not. Cartographers in particular will use scale this way, but when writing a paper, you have to be quite precise about these things because you know that your audience is a particular audience. And so I'll never use the term scale to mean extent in a geographic paper, because I know that people are going to want to separate those out, right? Even though in English, I know that it's commonly used.
So the next thing is the update from my thesis and journal. So I shared the draft thesis with my committee members yesterday. I submitted the article to the KG Journal this week, and my presentation is scheduled on February 30 from 12 to 3 p.m. And so that's a big update from my
Yeah.
this week.
I can't believe the submitted article was just a week ago. But yeah, that was Monday or last week, wasn't it?
No, it was Tuesday.
Was it Tuesday?
Yeah.
Oh, gosh. Oh, it feels like a million years ago.
Yeah, I was actually like when I actually got confused, like, was it that last week or like it was a week before? Like,
Crazy. Well, awesome work. This is a big week.
Yeah.
Yeah.
it was a big week. So yeah, and my goals, just one goal is actually just to prepare the thesis presentation. But other than that, I have actually started on a small project. So that's a voluntary one, definitely. So that is like on February 21st is the International Mother Language Day, and it actually generated from Bangladesh, because Bangladesh was once part of Pakistan. And we got the liberation like in 1971, but back in 1952, so there was an ordinance passed by the Pakistani government that Urdu is their mother tongue and our mother tongue is Bengali. So they told the Bangladeshi people that Urdu shall be the mother language, the official language for the whole country, but these two languages are completely different. So there were like big processions and shots got fired, people died, and then from 1952, like 21st, the date was 21st February, and the 21st February is celebrated as the Martyrs' Day. But I guess back in 2000, the day got recognition as the International Mother Language Day by UNESCO. So this time, from our Bangladeshi Students Association, we are celebrating the day from Virginia Tech, and not only we are representing Bangladesh, but also like all the languages like we have in Virginia Tech, people from all over. So the project that I'm working on will be like, it's a VR project, so people can wear the VR glass and they will move around, and there will be a map of the world, and wherever they go, they will like a sound will pop up with like maybe hi, I am from something, like we haven't figured out the statement yet, but it will be in a different language format. So we are just making a list of like, okay, I have friends from this country, this country, this country. So yeah, we are making a list of it.
Yeah.
Like people, like where 4 or 5 people are working on it. So I think it will be a very interactive one.
That's great.
So
Who's doing the?
oh, so
Okay.
yeah, so like there are 2 of my friends who are actually working on like human computer interaction department. They're PhD students, so they're like, oh, okay, yeah, we can do this. We just need the data. Like, okay, yeah,
Awesome.
let's work on this.
Oh, it's fun.
Yeah, it's cool. So, yeah, that's it.
Cool. Okay.
Sure. I have to.
Okay. Yeah. Thanks for coming.
Can I also talk about the lab, relab things? What do we call that? The training part, the training modules.
Sure. Yeah.
Yeah. Can I talk about that this Friday?
I'm not sure about Friday. But why don't we communicate on email and we can set up a time?
All right, that's good.
Yep. See ya.
Let's see. Thank you.
So first thing that I found what I thought was a cool company. They're trying to do real-time imagery, but real-time really just means within the last 90 minutes. But thought that was pretty cool. They have about 60 satellites up that they try and get to orbit the Earth every 90 minutes roughly. And so I thought that was pretty cool.
Do you know if they, so you might not know enough about the mechanics of this, but 60 satellites, when they want to cover it, like, do they talk about like a resolution that they want to be able to, like, we want to be able to provide 1 meter resolution imagery within 90 minutes, or do they have?
I wasn't able to find what resolution they try and get. I think they just care about like they try and track world events that are like ongoing. So I don't think they care about the resolution unless their AI system like finds a world event. So like a wildfire or something.
Okay. Do they, what about, do they have to move any satellites, or do those satellites in orbit and they just like, they've got a way to like do the orbits in a way that like this is guaranteed, or is it like, we think something's happening here, like initiate a slight adjustment to this satellite?
From what I understand, they do that, where it's
Okay.
like if there's an event, then they have more satellites go to that area.
Okay.
And like track that sooner than 90 minutes.
Okay.
That's cool. There's a company that does similar thing called Planet.
Yeah, I was just about to mention that
Yeah.
as well. Yeah.
They have a bunch of, like, they're called Dove satellites,
Mhm.
and the benefit is that they're a lot cheaper than like a traditional, like normal satellite, so they have like tons of them out in space, and like they
Like
also have-
thousands of them.
Yeah,
I think Maxar has a similar one too, but I haven't done as much research. And then did a lot with the Emlyn Reach this week, figured out how to collect points with effects. And so I collected 2 last Thursday and then 6 on Friday. I downloaded all that data and I was trying to put it into ARC, but I couldn't figure out how to visualize those points. I tried a couple of different things. I defined the projections for all of them as what, as the NAD 84 with the 2011 revision, I think.
Mhm.
And I was having a lot of trouble with that. And so I think I just need to spend more time trying to fix that. I tried creating X and Y fields and then add X and Y. Couldn't get the things.
Okay, let me take a look at that.
And then
Hmm.
we went to the drone park on Friday. We wanted to test fly the Phantom 2, but winds prevented that a little bit. And also the drone did not react how we thought it was supposed to, or how it was supposed to. So we did not end up flying. Let's see, oh, and the drone park was having issues with their library services. So that page is not accurate for them. They do have a Phantom 4 that we can rent out. We just need to email them about like if it's available or not. So their website. And then I wasn't able to find what kind of gimbal connector the Phantom had. So I think I need to do a little bit of research.
Quick question on that.
Yep.
So. Yeah, keep following up with the gimbal thing, because that'll be critical issue. Why does the drone say Airwolf on it?
Oh, they name their drones.
Ah, sweet, that's what I was wondering. Have you guys seen Airwolf?
No.
No.
Oh, you should watch Airwolf sometime. It's a 1980, let's call it 4 helicopter show where Airwolf is this like super high-tech, amazing helicopter, and it's all about their adventures of their small ragtag group of people that go out and help the people doing stuff with a cool helicopter. It's a great name. Yeah, and a fine show.
And then I meant to delete this slide, but we did send out an email to Office of Undergraduate Research to see if they had funding, but unfortunately they did not. And then goals for this week is to update the lab wiki with the new funding information that we have. Try and figure out how to visualize the emlet points and then continue practicing with collecting GCPs and then decide on purchases hopefully this week.
Yeah, the purchases, I think we can probably take care of tomorrow.
Yeah.
Very good, cool, thank you.
So I just completed the indoors ArcGIS indoors tutorial.
Ah.
And I found something that was really interesting. I saw the software components and it basically talked about ArcGIS Enterprise and the Enterprise GIS class we are taking. I'm seeing Enterprise the term everywhere, even in every like job descriptions. There's a lot of Enterprise going on, and they just talk about it very briefly. And I'm like it, but they talk it as a very essential component of ArcGIS indoors. And the other thing they are talking about is publishing everything online. So I was thinking ArcGIS indoors is something they want to do to like over the WebGIS stuff. I'm not sure about like. how they're going
Yeah,
about
I
it.
think that they imagine indoors as being like a real-time dashboard kind of a thing, right? When you want to know what's going on right now. It's interesting, you'll know more than I do, maybe you do already, like how critical of a thing that is, because some of their use cases are sort of like, let's plan how we're gonna organize our office seating.
Mhm.
And I'm like, well, that's not, you don't need any real-time information for that. Like, that's I don't know. I mean, you can have all the data online and ready to have it, but that's different than sort of like a enterprise to me. Well, partly is about sort of like collecting data for an organization, right? So that like, if you need that stuff, it's somewhere on a server that you can access and not like call somebody and like, hey, do you have the shape file for whatever, you know, like you want all that stuff to be centralized. I don't know. Anyway,
One thing that stood out to me was all of these use cases they talked about were not very attractive. Like they talked about stuff like I am here right now. What do I get do to get there and stuff? But I thought they can do so much more with the stuff they have. And one other thing that was like privacy issues again. They were showing stuff that compromised everything.
oh yeah,
Yep, the tutorials showed like, I don't know how they are going to use it, but the capabilities look good. And they're basically trying to structure office and smart offices. That's basically what they talk about it all the time. So this was one tutorial I finished. I also ended up landing in a YouTube playlist talking a lot about ArcGIS indoors. And then this is a part of something that's called ArcGIS into fundamentals.
Yeah.
And I went through the courses, and some of these courses are free, like the one I took. And one of those courses is like $2,685, and it's instructor led. And I was like, what are they trying to do? Isn't that too much for an instructor led course? But they have 10 courses and something that says requires maintenance subscription. So these are the 3 types of courses they had. I was able to go into the requires maintenance subscription course, but I did not go through all of it. I don't know when they lock it, what we cannot access in that particular course.
yeah, I'm not sure, but I think we should be able to have everything in there except for the instructor-led courses.
Yeah,
Probably, yeah.
like usually like if you log in, they allow you to do all the courses.
Yeah, so I went through one course. I have completed like partly one more course. There's like 10 of these, so I'll probably update on what happens when I take like one request.
Yeah, do you remember there was a like a Esri experience and doing the Esri of quarters, and there was like an indoor GIS section.
Did they? I never went in there.
Oh, okay. So they had this indoor GIS experience thing, and they were showing like, yeah, this like this data has like high precision, but what they were mostly trying to do was to like deliver documents like within the office. Like there was a robot, and they were using the indoor GIS so that the robot can move around within the office, and there was a robot for the demonstration.
I saw the robot.
Yeah, so that was for the indoor GIS thing, and they were also talking about like for like I don't know, like for security purposes, like you can actually have like an inventory of the stuff that like within a space, and
Yeah.
something goes missing or something, you can track that down with ArcGIS doors. But still, that's not too.
That's not.
Yeah,
too
I think
interesting.
they're
Yeah,
still casting about for like
Yeah.
good use cases. I'm sure they'll find it. I do agree that this is a good, but I don't think that they've really come up with the answer yet. One of the things that I'm really interested in is the indoor positioning system component, because I don't feel like that stuff works super well. So that's a kind of a thing to pay attention to as you're going through this. I sent out a note to the person that I talked to from Elizabeth when Seth and I had the meeting. And he was supposed to put me in touch with someone. Maybe we need to follow up on that. I'll make a note.
The indoor positioning system were like one of the major components of this, but like we still have to like play with the ArcGIS indoors toolbox.
Yeah, that could be a thing. I don't know if you guys have figured out a class project for the enterprise class yet, but you know, integrating anything from like Percept should broadcast that stuff via MQTT, which should connect up through enterprise and should be able to, so I don't know, I think we've got a potential chain of like the LiDAR data, but the indoor positioning stuff is also really interesting,
I
so.
was just imagining like what you just said, and I thought about like I work with the MQTT message system, so we were just publishing text messages when I did that. Would it be like just publishing the JSON text in with the MQTT into another server, or would we be publishing files?
I don't think files, I think, isn't enough, I don't know enough about it, I think we'd have to see.
So like I was playing with NumPy, and then I felt like NumPy has a lot of capabilities I'm not aware about, and this is a problem that came up that Dr. Pingel talked about in the algorithms class, which is the 8 queens problem. And for those of you who are not familiar with it, we are supposed to put 8 queens on a test board so that all of the queens are safe. Right, so I couldn't even think about it. Dr. Pingel showed a solution, and I was planning to just replicate what you did. And I was playing with NumPy, and I was able to create a chessboard that looked cool, so I just put it there. And then I basically did try to make the solution. I used the np.trace function that was really cool. And one thing I did wrong was I sometime maybe undid what I did, and I lost some code. So I basically tried to check all the pieces by giving it a list of all the positions, all 8 positions of the queen, and it would check if that particular list is a solution to the 8 queens problem. So this is what I did. I placed 8 queens as a list on a list called positions, and I input the list as the parameter for that function. So one is a list that is always unsafe, and the other one is a safe one, and these are the 2 results I got. So this has one mistake I'll need to fix. I just need to rewrite the code. So this was pretty cool. I really like NumPy, and I'm planning to work on it a little more. The other thing I did wrong this week was I lost some slides. I like from the Friday first thing, I just got motivated and I looked at Dr. Carstenson's lectures back from the class when I took it, and I converted JSON files to shape files.
Great.
So that was something really cool. And the other thing I was trying to do was, since we looked at all the noise and stuff, I was looking at some like use cases where they get rid of some polylines from a shapefile. That was particularly what we were looking at.
Yeah.
I thought like just looking at the length would not be a good idea.
Perhaps not, yeah, some of those jumps are big, is it?
Because like it is detecting one point continuously as a spiral, and it is a noise that we can always see in percent.
Okay,
So I was thinking of other ways to do it. I could not, and I think maybe looking at the coordinates and the relative positions through a JSON file as a database would be much easier than looking inside a save file.
Yeah.
I was supposed to put the slides for that, but I forgot. And this is one thing I just wanted to put in. So ChatGPT, I'm playing with it, and I asked it how chicken eggs are.
That's
different from
awesome.
cow eggs, and it actually gives you like an answer. And when I told it cows don't lay eggs, and they're like, oh yeah, you are right.
yeah, isn't that right? It never can put those things together.
And every other time you ask it, like if you start a new window, it will forget everything. It will again give you the same information. So I thought like, if you pay for it, maybe you'll get the right answer. So
Cow eggs have a distinctive and slightly gamey taste. This is fantastic.
nutritional value. Literally low in protein and contain more.
What's what prompted you to do this? This is a really interesting question.
Like this has become like one of the things I do when I become bored. I just ask it stupid questions. I even sent you one thing. Mike's mom has 4 children.
Oh, yeah.
I saw that one. Yeah, that's good. These are good.
I have a question about this. I've heard that institutions, some are really lenient and allow their students to use them and some aren't. Do you know about Virginia Tech's policy? Is it even
I don't
becoming a thing
I
yet?
don't think we have any policy.
Yeah.
It was a topic for discussion at the faculty senate about a few weeks ago. And only a few of us had even used it at that point.
Yeah.
And so I don't think we have a position on it. We're just sort of like watching and seeing what it can do. And I'm using it a lot in the algorithms class just to see what it can do, like asking it to write some code or asking it. Actually, that's an interesting one. So do you remember I said, I haven't gotten to the bottom of this yet, but I had it write a solution to the 8 queens problem, both the recursive solution and an iterative solution. I think the iterative solution is wrong.
And even the ones that I asked for it in NumPy, it didn't give me a right solution at all.
Really? Yeah.
I asked it like 2 different solutions, both of those did not work. And I know for a fact that ChatGPT is not the only one that gives you code. There's a bunch of other stuff as well.
Yeah,
I
maybe
don't
try
think
some of
we
those other
can
ones.
trust ChatGPT.
Yeah, I think that's the thing. Yeah, I think you just can't trust it. I think it might be right or it might be totally wrong and you wouldn't know. Yeah, it's neat.
So the other thing we did last week was we installed the Percept system, and I was just getting pretty interested about Linux. So I just put in an image that's basically the command that you'll use the most in Linux. And I found one thing that I was supposed to find long back ago. So this is a list of all Linux commands that someone posted.
That's awesome. I like both of those. Maybe we should print these out and put them in the lab.
I think this is like the number of codes you'll need for like, the basic things, and this is really.
Cool. Yeah, neat. I'm interested in printing these out and hanging them up.
So that's basically it. I went to the ArcGIS Endurance tutorial. I'm still going to go through the YouTube tutorials that they have. They have a lot of those, and maybe when I go to the S3 user conference, I'll meet someone to talk with.
Yeah, that's a good idea.
And I worked on the JSON files a bit, so I will still continue working on automating and like maybe replicating Dr. Pringle's code by myself. And then the revisions and proposals, I have like listed those out. I am ready to go to the user conference, and I'll probably be working on the Percept JSON files and ArcGIS tutorial next week.
So this one, I want to show you and Addison how the code that I wrote does it. So I did it in pandas instead. And this will make a good comparison in the algorithms class. You can sort of talk about why in the world would we ever take apart a JSON file, and it's a good application of it. And then parallel with pandas in a way to take that data apart without having to get into sort of the details.
I didn't do it in pandas. I just did the list dictionary in
Yeah.
version.
Yeah, but it'd be good to compare those. I'm having fun with that comparison in class. And if I didn't have Bill's stuff to work from, it wouldn't even occur to me to solve some of these problems the way that he solved them. So I think it's really interesting. But on the other hand, I think that's the way that Bill solves them was a little bit more like a traditional sort of a programming way. So I don't know. I'm having fun with the juxtaposition. Jared, did you ever take the algorithms class?
I didn't. I feel like I missed out on a lot of useful things.
Huh?
Are you feeling big there?
I know. Maybe next time.
It'll be cool.
If you want, like what I experienced with ChatGPT is like if you want to get a good output, so you have to talk with it like 5 or 6 messages, letting it orient with the topic that you want answers from. And then if you ask questions, but not like a big question, like break it into like small questions, and then it gives actually like good answers.
Yeah.
Like if you just ask them like big questions, it will never give you like good answers. So.
It reminds me a little bit of like, being a good Google searcher, right?
Yeah,
Like,
exactly.
you kind of have to know how to do it.
Yeah.
Will it ever correct that question that you just asked about?
It will. So
Does it have logic? Will it say that cows
I
don't lay
tried it twice in different windows, and it basically gives me kind of the same answer. It rephrases the answers, but unless you tell it cow is a mammal, it will say cows eggs are a real thing.
Yeah.
But I just like the fact that this has been like people have considered it as such a useful resource. I just like the pointing out the errors.
Yeah. No,
So that
it's
people
super
don't depend
useful.
on it too much. I read an article saying, will ChatGPT change the way we Google stuff?
Maybe, yeah.
Because like people now know that even Google probably works on like same kind of a thing.
Yeah.
So
Yeah.
how you search like gives you a particular kind of reason.
I had to do a comparison of tax rates of different states. We were like talking like which tax rate is higher, Pennsylvania or New York? And so I put that in there. And that was pretty interesting. It was like, this is the tax rate. This would be a problem that would be difficult to Google, right? Like, because like you're not going to find an article that compares those two. You might find a table that has everything, but it was nice to be able to sort of assemble the data that way. All right, I think we're ready.
All right, so I did some work with Space Time Cube and also some of the stuff with the reflector. So just like to backtrack a little bit. Originally been doing space type cube in the past, there's been issues with annealed data. Basically the raster that we're using for the NetCDF is 1140 by 900. So each cube was 1 pixel. I give each cube in the space-time cube representing 1 pixel. There would be 1 million cubes that would be visualized. And I would have a value for each second. So then for 3,600 seconds of data, it's 3.5 billion bins worth of data. So when you try to run, for example, creating a space-time cube, it says we can't do this because you'll exceed the maximum size for like the program.
Which, just to comment, like, one of my frustrations is that at some point, 3.6 billion bins of data isn't even all that much data, right? Like point cloud LiDAR data can be in the billions, right? We often only work with stuff that's in the tens of millions. And so it's true enough that once you get into the billions, it's a lot, but it's not like I could load a 1 billion point data set into Cloud Compare and work with it. So I wish that it wasn't quite this bad, you know, like I will acknowledge that 3 billion is a lot, but
Yeah.
like 1 million isn't bad.
Yeah.
Anyway, all
I
right.
think generally, and not always, I think it's probably a little bit more optimized for working with some of the point data, and less so with the multidimensional raster layer, at least when you have as many, I guess, rasters as we do, or as many pixels as we do. So kind of my first solution attempt to go through this would be resize the raster. So I took one from, I guess, 2 Fridays ago. Because I think the data was working at this time. And to basically take the NetCDF, use the make multidimensional raster layer tool, because that's what space-time cube wants in order to make the cube. So going through this, pulling out intensity as the like main value. So we don't really, I haven't really used max. And basically what it does is it'll output this multidimensional raster layer. It's good because as you can see, the time is getting pulled over correctly. In the properties, you can see the time is going from 1 p.m. on the state to 2 p.m. on the state. And then you can preset the time interval. So I did it to make sure that each step was being recorded as 1 second. Which is good. So just to resample it first, I tried moving the cell size from 0.05 to 5. So basically scaling it by a factor of 100 on each side, which in theory takes us from I guess 1100 by 900 raster to an 11 by 9 raster.
Still at 1 second slices.
We'll get there.
Okay.
So this is what it ended up outputting. So what it's doing is when it's doing a nearest neighbor resampling, it's saying, well, okay, there's no data here. The majority of what's here is not actually filled with data values. So that's why this cube was blank, or like that's why this one is blank. It needs to be in a section where the majority of the pixels are actually filled in and do have values for it to like show up as data. So we only have 3 of these little sections where data was represented. And honestly, this was just a test to see, can I scale it really big and then run it on a really big file before running it on a smaller file?
I'm impressed that worked at all. This was great.
It did work though. So we've resampled the NetCDF, and the format itself is still an NetCDF, but we'll get there in a second. So I was messing around with this for a while, just changing the cell sizes a lot. And anywhere between about 0.2 and 1 is a decent size factor. I thought that 0.3 was pretty good. So it's a factor of 6 times larger on each side. So for every 36 pixels, we now have a single pixel. And that does scale it down a pretty large amount. So you can see here's the reshaped one. If we compare that with the previous, we do lose some of the details like in the walls and stuff here.
And I'll note that this was actually a big decision to make early on, right? Like, what resolution should we be recording this data? And we kind of just pulled 5 centimeters out of a hat. because when you render it, it looks kind of nice. But I don't, you notice that like when we look at the animation, like there's this flutter, right? It's like here and then it's there and then it's here and it's there. So that kind of suggests that like that's probably too fine of a resolution anyway. I think this is probably a much better resolution for analysis. Like it doesn't look as pretty when you put it up on a screen, but it's probably better from an analytical perspective.
I'll have to check the timestamps with those also, because now I'm seeing that like. These people, I guess, still didn't manage to make it into here, but it might be that this is from a different, it might be that this guy analyzed it at a different time slice. So then I was testing out different resampling techniques to see if there were any major differences between them. There's not a whole lot of difference between them. It seems like majority and cubic kind of seems to work a little bit better. Majority had more of like it kept higher intensity values, where it's like you see nearest missed a lot of spots, like for example on this wall. Majority kept a lot of the spots on the walls a little bit better. So like we can see with majority, there's actually a lot more pixels that were shown in, and same with cubic as well. Cubic was kind of like a medium. So I think these two are probably the best between these. But then let's go ahead and try to make the space-time cube from this, resampled raster layer. So I took the cubic one for this because it was I think it was the last one that I did, but I might have taken the majority. But now that it's resized, there won't be too many bins so that there's like more than the 2 billion that are necessary because we've scaled it down by a factor of, I guess, 36. So the input is now like the pre-shrunk raster. And you have an option to fill empty bins. So for example, if there's all of this space here where there's no data, it can take, again, like nearest neighbor resampling and stuff like that to kind of, I guess, interpolate and say, well, if there was data here and there's data here, we'll fill in these empty spaces with data also. Obviously, we don't want to do that for this because our data is not continuous. But if you are working with data, then that would be a pretty neat kind of method to work with. But didn't like this. And to go back to what Dr. Pingel was saying, did it keep the time slices? It didn't when I was resampling the raster, which is why I ended up failing. It said it failed because the new NetCDF that I created when I resampled the original NetCDF was no longer multidimensional. It just kept, I think it kept either the last time slice or the first time slice. Whichever time slice I was visualizing, which I thought was really surprising that was the default. And I was like, there's no way that resampling a raster means that you can't get the you shouldn't be able to lose the multidimensional layer if you don't want to. So I did some research and found out that you don't have to lose the multidimensional aspect, but I'll get back to that in a second. There's also one called make a space-time cube by aggregating points. So I converted our raster, our NetCDF raster into points to see what would happen there. I wasn't sure what was going to happen just because how does it take an hour worth of time data? And it doesn't look like it pulled like any of the logging paths. So again, this looks like it just took a single
slice, yeah.
a single time slice there. And I wasn't expecting this one to work. I just kind of wanted to give it a shot.
Yeah.
But then again, now when you go to actually make the cube, it's like, where's your time field? Well, it didn't pull over the time field, so you can't progress any further than that. So going back to resampling the raster, I did find that the tool does support multidimensional raster data. You just have to save the output to a .crf file, which is like a cloud reference format or something.
Yeah, I don't know that one.
So I did do that. Let me see. So when I went to resample it this time, I have my X and Y as 0.3. And then if you actually browse to where to save it to, you can type the .crf extension and save it that way. And this is where I am now because I was running this last night.
Okay.
And it was going through, and I was on I was doing this on my computer. It was going through at about 1% per minute. So what it's doing is it's resizing 3,600
And this was an hour.
Yes, yeah, it's resizing 3600 raster images. So it was going through about 1% a minute, so almost 1 minute per 1 minute of data, which is surprisingly slow.
Super slow.
Yeah. So I decided that I was gonna go to bed before it was finished, and it was also in the process of melting my computer.
Yeah.
So I'm gonna probably try this on Maverick or Goose at some point this week.
Yeah.
And seeing if that can run a little bit faster, and then I can also run it in the background. And then just a little bit on the CID, but I do think that this is going to work, which is good. Once this runs .crf, I can add that into the like make space-time cube, and then it will have a good amount of bins to where it should be able to run the analysis. And I'm excited to see how that outputs. So last Monday, I went to the CID building with the reflector. And I walked around for about 30 minutes and like placed the reflector on the table for a little while. And you saw the picture in Dr. Pingle's lab report of the shapefile, and there was there was a loop, basically a percept object that had been tracked, and it had like walked a loop around the building. That was me, because I remember walking in that way where I started at the table, went into the hallway, came around, walked around the room, and went back to the table. So it's good to know that Percept was pulling data, because I don't think the actual data was being charted at this time. There was
Yeah, not the raw logs.
yeah, the raw logs were being charted, but Percept was still running. And the data output is in this JSON file format. So you have to do a little bit of processing to pull it into a shape file. But that's where I am now for that one.
Awesome.
So my goals are to finish the coding bat exercises still. I still have a couple more to go. And then explore more with the NetCDF. I really just want to get onto either Maverick or Goose and process it there. I think it'll be a little bit quicker and a bit easier. And then doing more with the trial data. So next week, run some of the NetCDF resampling, I guess this week. And yeah.
Cool. And run the reflector back over at CID one more time.
For the like the raw data.
Yeah,
Okay,
if you don't mind.
definitely.
All right, awesome. Thank you. Good progress on that one this week. I was going to ask you about it during I think Shashank's presentation. He was talking about the Arc Indoor stuff, and I was like, I wonder if Addison's working on the space-time cube stuff. So I'm really glad to see that you were. Can you see if aggregate works?
Instead of resample.
Instead of resample.
Okay.
So the difference between aggregate and resample. I don't know if I'm going to be able to describe this very well. Aggregate is going to basically, if you've got like 5 by 5 pixels, and you want to, it'll like sum them all up.
Okay.
Instead of like
Choosing
what's
one
going on
or-
in the middle of it.
Yeah.
Is kind of what resample is a little bit better for. It's not always clear which way is going to work depending on the data, but I think in this case, aggregate is probably going to work. But I don't know if it'll work on a multi-dimensional data set. The other thing that I think you should try is, so if you load one of the NetCDFs in NumPy and you get the full data set, NumPy has ways to resample. I don't know what would be the right answer there. OpenCV might have some tools to do that, like to condense it. Because you could condense not just on space, but time, right? So one way would be to, go from 1,000 by 1,000 to 50 by 50, right? But still keep all every second. But you could also sample this down and then sample that down too, so that instead of every second, it's every 10 seconds or something like that. And there's no reason, and you might want to collapse those at different rates, right? So you might want to go from, let's say you went from 10 pixels on the spatial side, right, to go, or you did a factor of 6 here, which is fine. So like, let's say you do a factor of 6 on the spatial side, but you want to do a factor of 10 on the time side. So you can condense at different rates, depending on the dimension. X and Y would be the same, but times might be different because a second is the same as a centimeter. So cool, very good. Thanks everybody. Jack, any questions?
This lab is based off of Top Gun, is that what I'm? That's something I picked up on. I
Yeah,
not thought about it very much.
It's gone through different iterations, but you know, a couple of years ago, the guys that were in here got really into Top Gun. This was before Top Gun Maverick came out. And so we had a contest to name the computers, and everybody kind of came up with names, and they decided they wanted to name that one Maverick and that one Goose.
Okay.
And that was the spawn of the shirt.
Yeah.
Once we got those two, and so it kind of picked up as a theme. So yeah, now it's, I guess, a thing.
Cool. Cool.
Yeah.
No, I don't have any questions. This was good. Just, well, for y'all who might not know what I'm doing, why I'm here, as part of my job, I'm making videos for all of our majors, highlighting undergraduate life, but of course it involves graduate students. But I really want to focus on hands-on stuff. And so for geography, there's like 3 areas of study. You have the human, the physical, and then this stuff like the GIS, geospatial. So I want to see what projects y'all have going on that I can stop into and film and talk to y'all about. But no, this is awesome.
So one of the things I think that'll help, like you guys got some video of like taking GPS points where we've got like equipment out there,
Yeah.
flying drones, stuff like that. But for some of the stuff that you guys are doing, be thinking about like what's on the screen that's interesting that we could like
Absolutely.
capture.
Yeah.
You know, if you're like got a point cloud that looks really cool, or you've got, you know, something that looks, you know, a thermal map that we're looking at, a 3D thermal map that we're like playing around with. Be thinking about like that as you're doing it, and then whatever you want to do to capture that, capture 10 seconds of that, or 15 seconds, and then, you know, pretty soon you wind up with a pile of that stuff. And lab meetings and stuff are good places for that, right? Like if you're doing a thing, record some video of you playing around with that, and then those are embedded in the PowerPoints, and we can get them here that way. So
Yeah, thank you.
Yeah.
I mean, I have a lot of ideas, and so, you know, I can talk individually, but even if I could get like drone footage, I mean, I think when y'all go to the drone park, you can record, and can you get access to that footage? Yeah, I mean, even something like showing you flying it would be cool, you know, to put in a video, but yeah, especially on computer screens, I think that's often overlooked, but I mean, students will get here, and some of them will want to be in this lab, and so they want to know
right
what they're getting into.
a lot of it, you know, we look at a lot of images that are very colorful and dynamic and
Yeah.
interesting, and they make for good little like 2 or 3 second like inserts into like
Yeah.
a bigger thing. So yeah, just as you're doing stuff, just think about stuff you could record and record a little bit of it.
Yeah, and also shoot me an email if something pops up. Like last Friday, I think, or maybe even Thursday night, Tina texted me and said, "Hey, I'm going to the drone park tomorrow at 10:30." My schedule's pretty flexible, and so I showed up. Even though they didn't fly, I still got some good footage. So if y'all ever have anything, shoot me an email.
Very good. Take
Yeah.
care.
Yeah, thanks.
All right.